really grateful for the opportunity of being here and that everyone is here again, non-sleeping. Let me start with our project, Ideal STEM Academic Working, dealing with the excellence mandate in the context of STEM academia. Let me start by introducing the team. Help me, please. The team is very interdisciplinary, and it consists of scientists of very different disciplines and career stage. We are Arianna Montorsi, Greta Temporin, Maria Sherbina means me, Luca Falzea, and thanks to Professoressa Alessandra Colombelli, who also kindly contributed. So what we are exactly doing. We are all are aware of STEM gap, and besides the huge statistics, besides the situation of horizontal and vertical segregation, the idea of STEM gap and the idea of the factors behind those STEM gap is somehow associated with individual characteristic and social characteristics, but not academic characteristics. So while those inequalities are clearly visible in aggregate statistics, they tend to be very weakly problematized within academic organizations themselves. As academia is often framed as a meritocratic and gender neutral environment, now by default, unequal career outcomes are not associated with academic processes themselves. And this tension between strong visibility of inequalities at the level of statistics and their visibilization at the organizational level constitute the starting point of our research. To understand the roots of those inequalities, we are going to Joan Acker theory, to gender organization theory of ideal worker norm. Acker starts with the idea that the organizations are not neutral themselves, they are gendered, and some behavior, some particular appearance, behavior, standards, and norms are privileged. And this inequality is produced through everyday organizational processes, including job design, evaluation criteria, career models, and informal expectations. And those who are fit in this kinds of behavior and norms appear to be ideal workers who are fully devoted to work, constantly available, without any care responsibilities, without any emotional ties to family or friends, without any personal life, and those who are able to demonstrate uninterrupted productivity. The ideal worker norm works on three levels: individuals, group, and organizational level. Individual level shapes self-perceptions, aspirations, and feeling of belonging. The interactional level involves expectations among peers, among colleagues and supervisors, and organizational level, it influences hiring practices, promotion criteria, and definitions of excellence. And academia, it's a kind of very precise situation of ideal worker. Who is ideal worker in academia? Who is those ideal academic? Well, those who are devoted themselves to academia, in particular to STEM academia, those who publish and not perish, those who, of course, have no personal life outside of science, but all personal life is within, and those who are part of academia. We are trying to understand how it works through life experience of scientists themselves, how those ideas influence their lives and behavior, and what is it. By the way, research based on Dewey scientist test reveals that who is the scientist. You see, white male, maybe self-isolated, maybe middle-aged, solitary genius, detached from the world of ordinary people, and there is a woman. Woman is the other. Woman is those who don't belong, who doesn't fit. And she needs justification why she's here. Why she's here? Maybe she's a wife, she's a colleague, maybe she's a daughter, sister, member of the group or something. So those ideas, those perceptions, it leads to invisibilization of her story of science. And it leads to Matilda effect and to erasing real women scientists from history of science, even from history, not her story. And why? Of course, we heard a lot from the speech of Professor Renier. We heard a lot about those double system of stereotyping and self-stereotyping that reinforce each other. Stereotype threat as a result of stereotypes from outside reinforce each other, creates mathematical anxiety, confidence gap, imposter syndrome. It is reinforcing by so-called hidden curricula of universities as organizations, as biased AI, and it comes to the second level, which starts with gender discrimination, maternal penalties and paternal bonuses, and so on. So even when women found their networks, they face challenges in mentorship because women mentors are few numbers. And also they have a lot of care, academic care responsibilities. And STEM academia itself is gendered. STEM academia itself is constructed on the idea of otherization of women, because technology, machines, and industrial production itself is historically constructed around men bodies and masculinities. So STEM academia is the great example of those gendered organization. It offers the possibility to study clearly conflictual ideals of what research should be, due to its particular connection to industry, technology transfer, and money-driven projects. And we have two research questions. How is the ideal STEM academic model shaped and or challenged by STEM academics of different genders and roles? And how do personal and organizational norms over the ideal STEM academic intersect and influence one another? And now I'm passing the floor to Greta to more important part of the results of what we did. And
thank you, Maria. So moving on to the empirical part of our study, I will present briefly the national context, which is the context of Italian academia. We chose this context, of course, for proximity, but also because we thought it was an interesting reflection of the European Union data when it comes to gender segregation in academia and in STEM academia specifically, but also because we thought there were some specificities related to the context that made it an interesting case. For example, the increased precarization of academic careers related to university reforms that affected young researchers in general, specifically women young researchers, but also the fact that, for example, Italian academia is characterized by mandatory teaching assignments and duties that are formally equal for all research roles and for genders, which made an interesting case also to explore differences when it comes to academic housework and teaching assignments. When it comes to the methodology, we conducted 28 semi-structured interviews within an Italian technical university in a sample of academics that were mostly with a predominance of engineering profiles, but all from STEM disciplines. It was a sample that was balanced both for gender and for academic positions. So we could identify 4 main groups of interviewees: junior women, junior men, senior women, and senior men. You might notice that it's not perfectly balanced by gender, and you may wonder why. It was because it was very difficult for us to reach out, especially to junior men. We had a very, very low response rate from junior men. So at some point we were satisfied also with the balance in representation, and we decided to move on. All the interviewees were informed in advance about the scope of the research, especially of the fact that we were interested in the gender dimension of the ideal academic model. And provided, of course, informed consent. When it comes to the data analysis, the interviews were conducted in Italian, but then the transcript were translated to English for analysis. And we approached the transcript through a thematic analysis with an inductive coding approach. And the coding process was reiterative. Basically, we coded all the interviews separately, and then we held meetings to confront and identify common patterns and macro categories. And we did it again and again until we reached consensus on our interpretation. So let's move on to the result. The first gender differences actually emerged from the very beginning when we asked our interviewees to tell us about their career so far and the story that led us to have the academic position they had at the time of the interviews. And we could notice that the men in our sample predominantly told us a story that we labeled as a linear career trajectory. So they did their PhD in the same disciplinary field in which they had their masters, and then pursue an academic career in the very same field with little to none career breaks. They reported international experiences, and also when describing their daily work, there was mostly a story of overlap between research, teaching, and impact and other university mission, with a very prominent story of technology transfer, for example, which was very interesting, especially in relation to the STEM context and the context of applied science, because technology transfer and connecting research to technology transfer is usually prestigious, it's remunerative. The women, on the other hand, told us a story of mostly non-linear careers, non-linear career trajectories, mostly related to structural barriers. So they were more likely to report career breaks or career changes, or also scientifically disciplinary changes. Maybe they did the PhD in a certain field and then moved on to do research in another. And they reported high level of interdisciplinarity. This interdisciplinarity was often like a byproduct of this career instability, but also it was reclaimed proudly as a choice by the women in our sample. So also in the construction of their research team, for example, they told us they privileged interdisciplinarity as a choice of as a criteria. When we interrogated them on the drivers, so the main factors that convinced them to pursue an academic career, while both men and women likely said it was a growing love for research and interest, men were more likely to tell us that freedom was a main factor for them to pursue an academic career. The fact that academia granted autonomy and freedom and flexibility, often in comparison with the private sector. When it comes to women, they were more likely to connect it to social impact. So a communal disposition, what they saw it was an opportunity in a STEM academic career to make a positive impact for society, especially when it comes to environmental sustainability, for example, but in general, grand challenges, I would say. So after we asked them to tell us the characteristics that, in their opinion, a person who will do their job at the best, so the ideal academic, in their opinion, should have. And we managed to isolate four macro categories of skills. Relational skills, which were related to skills that are helpful in the interaction with other individuals in general. What we call the networking skills, which are skills helpful in the interaction with the academic world and the research world. Technical skills, which are more related to the specific domain of expertise, of course, of the academics. And lastly, but not least, principles and values. The main difference that we noticed was that the men in our sample were more likely to list characteristics that are generally valued for career progression in academia. And I'm talking specifically about networking skills and technical skills. So both junior and senior men were stressing the fact that an ideal STEM academic needs to be good at disseminating the research, networking, self-promoting. One of our interviewees told us that you have to be the entrepreneur of yourself when you're doing STEM academia. And of course, being an expert in the disciplinary field, also show curiosity, a curiosity-driven mindset to make new discoveries or to problematize existing knowledge. Especially senior women, were likely to mention these type of skills. But we found that they were more likely to put the stress on relational skills. So here, there are nuances that, in our opinion, are worth the attention. For example, both senior men and senior women told us that in order to be an ideal academic, an ideal STEM academic, you have to be a good teacher. And it was a point of common between senior men and senior women, also because they are teaching for far more time, in comparison to their junior people in our sample. But while the men were more likely to stress the importance of knowledge transfer to students, to equip the students with skills that can be helpful in the outside world, and especially in the job market, we noticed that women were more likely to stress the importance of being a good mentor, to provide support, to do the emotional service, not only for students, but also for junior colleagues. When it comes also to empathy, we found this unexpected alliance between senior women and junior men. So both these groups were very much likely to mention empathy as the main characteristics to be an ideal academic in STEM. For senior women, it was an expected result, but when it comes to the literature for junior men, it was unexpected. But we will go back to later when we go into the final part of the results. Finally, when it comes to principles and values, we noticed that junior women and senior women were more likely to mention as the first characteristic to be an ideal STEM academic, integrity and critical thinking. And we lead that to the fact that a lot of these women decided to pursue an academic career to make an impact in society, to make a positive impact when it comes to facing grand challenges. So in order to do that, in order to be an ideal STEM academic, you have to have solid ethical and moral ground. You have to problematize your research, also in terms of political impact, of social impact. Another interesting fact is that we found not much a gender difference, but a generational difference when it comes to separation between personal and private life. The junior people in our sample were likely to mention, like, you need, in order to be a good academic, you need to separate between your personal life and your private life. And that was really interesting. The last question that we asked was about the organizational model. So we asked them, in your opinion, is there a certain type of STEM academic, a certain model that the organization you're part of is pushing? And here you see the result color-coded from red to green. As you can imagine, red is the most critical group and green is the less critical group of this organizational model. And unsurprisingly, junior women were the most critical of the organizational model that they perceived to be pushed and promoted. And they critiqued especially what we called also in our title, the excellence mandate. So junior women were more likely to tell us that, in their opinion, the ideal STEM academic pushed by the organization was one of constant and perpetual excellence in all the fields, in all the tasks. So the organization demanded excellence in research, in teaching, in impact, in technology transfer. And in their opinion, this is simply not possible. This is exhausting and unrealistic, especially for the young mothers in our sample. Senior women were also likely to tell the same story. They said they were more like neutral, I will say diplomatic when it comes to the organization. They say, okay, our organization, it's still good if you compare it to other situations, for example, in Italy, but it still fosters a very competitive and assertive model that undermines collaboration and well-being within the university. Junior men and senior men to this question usually answered, oh, there is no ideal model that is pushed by the organization. In this organization, you can find your space independently from the type of academic that you want to be. But at the same time, junior men said that the organization at times can be unsupportive. Academic career provides freedom, so provides flexibility, dynamism, something that, for example, other types of job don't provide. But at the same time, they suffer from the increasing precarization of academic careers, and this push towards excellence, of course, is linked to the fact that you have to compete for your space in academia. And so they linked the unsupportiveness of the organization to the fact that you have to meet these very high standards to have a job in the future, and the organization doesn't always help you. Finally, the senior men were more likely to depict the organization in a very positive way. So the organization becomes a family, a provider of this freedom and autonomy, but with the fact that now that the organization provides freedom, now I have to give something back. Now I have to give something back to my family. It's very much aligned with the devotion mandate. Finally, not the men, but the women in our sample, when we asked the last question on the organizational model, were more likely, the majority of them depicted this model pushed by the organization as masculine. And here you can read a quote from one of our interviewees that depicts this as the alpha male model. So what the organization wants, what the technical university and STEM academia wants, is the alpha male, which is competitive, assertive, especially in terms of bringing funds, money, and industry collaboration, which are remunerative and prestigious. So going to some final remarks on the results, we found that there are gender differences and generational differences in the construction of the ideal academic model on a personal level. And specifically, we found this idea of the STEM academic the ideal STEM academic is for social impact related to the women in our sample. And the fact that when it comes to the organizational model, they don't find this stress on social impact, at least from their perspective. What they find is a push towards excellence that provokes a higher level of competition and emotional fatigue. We found also very interesting this masculine emphasis on freedom, which is something that it's granted by the organization and academic career in general for men. But this freedom translates into a sense of duty and belonging for senior men, while for junior men, it's more like a trade-off. So academic career is precarious and STEM academia is very competitive, but at least I'm free to handle my work with a higher level of autonomy in comparison with, let's say, the private sector. And also the fact that the junior people were also likely to say the organization is unsupportive to a certain extent, but there are still gender differences. The junior women were most likely to critique the standards that are pushed by the organization, so these excellent standards. Junior men suffers from these standards, but they are more likely to say that the organization doesn't always help them to reach those standards. They do not critique the standards in themselves. So here, to conclude, we have some future directions. We are working on finalizing the last stuff when it comes to the interpretation of results, but we are open to any feedback. For future directions, we want to explore better this side of men and masculinities in STEM, and how masculinities are constructed in STEM, are challenged, of course, by men in STEM. And also investigating how the hidden curriculum of STEM academia constructs and transmits gendered ideas of ideals of excellence, for example, and devotion. It's just a short bibliography, but I guess we're finished, and thank you for the attention.
I don't know if I will share also for this session.
I think it's okay.
So thank you so much. We have time for questions.
It's not so much a question as an observation. I'm very surprised at your junior women effect, because my impression, well, from my own field, is that the junior women just want to fit in, and it's only when the women become senior that they start being much more critical.
Mm-hmm.
And so the idea that the junior women have enough knowledge to even understand how crazy everything is sort of surprising to me. So I don't know if you have some.
No, definitely. So they were definitely the most critical when it comes to the organization, but they were not the most likely to depict this critique as the model is masculine. So when it comes to, for example, we had like some junior women who told us, yeah, the model is the macho man or the alpha male, but it was especially senior women. So it's true what you say. They are trying to fit in, but they do have the perception that the organization demands too much and is too much far away to what they realistically can give. But when it comes to the awareness of like the masculinity in this model, is especially the senior men, but also the senior women, but also some junior women.
Thank you for this presentation. I just I'm a bit surprised about your comment about the excellence. Why do they see excellency as a masculine thing? And in your research, if we're talking about the top and the excellence impact, I mean, at the end of the day, this is the work of the STEM, to achieve the ultimate goal is the Nobel Prize of chemistry, of science, of discovery. So I don't see that in your research, and I still don't understand why do some of them see excellency as masculine character.
It's a very interesting question, and I think we will reflect on that. My guess now is that excellence is not inherently masculine. I think it's a mix of excellence, competitiveness, assertiveness, but at the same time, what they depict as excellence is the fact that you have to provide a high standard constantly in tasks that are very different from one another. It might be related also to the Italian context. I said that so there are mandatory teaching assignments that are quite heavy for all professional roles, but at the same time, to get your habilitation, you only judged on research. So that might be a thing. Excellence in their case is that you cannot make mistake. There is one of our interviewees that you told us, for example, you cannot make mistake, not even where you're sending an email and you forget the attachment and somebody will come back at you to say, oh, you forget this. That's the excellence that is perceived to be required. And the fact that you have to provide that constantly in tasks that are very different among themselves is perceived not only as exhausting and negative, but just unrealistic. Like, I cannot do that. One human being cannot possibly do that.
Maybe it's not excellence, it's perfectionism.
Yes. But also, I would like to add that highly publishing rate is linked to stereotyping in publishing and publishing bias, editors bias, and a lot of biases in evaluation. And also, the nonlinear careers are linked, strongly linked to women and to motherhood penalty. So, linear career is less achievable for a woman. And it is really preferable for the organization, for the university.
That has changed. If I may add, especially what you just said for the editing and the scientific journal. In December, there was a national session in Science Academy, Institute of Science in Paris, with the European Commission, and they compared the editing factor, all Springer, Elsevier, Wiley, and everything. Because of the publish or perish culture, today the number of publications does not matter. Quality prevails, and the quality of the papers giving the editors is going down. So something has to change, especially with the introduction of artificial intelligence and the open data culture and the open source. So they sound, because the editor-in-chiefs and all the public, the scientific journal, including Nature, quality of paper are going down because of that culture. So that's why I say it has changed. So it is interesting now to really pick up on that. And if we are talking about gender equality, it will be very interesting to see who are the editor-in-chiefs of the journal. So things are changing, and I'm very happy. And it was a superb session. You can see it again on the internet. If you look at all the results, it's incredible to see how the policy of publishing in the scientific journal has changed today. And we have all to be focused on that.
There is something that might be interesting to look at, because at school, when girls are good in some discipline, they are often good in all disciplines, while men, boys specialize for some reasons in some disciplines. And here we might have the same kind of mechanism, because when women say we can't be good in teaching, good in research, good in scientific mediation, good in contracts, etc. And it's true that the universities and the schools say to their academics, we want you to be good in all these fields. But usually men hear that, but decide just to be good in research, and research is more rewarding than the other aspects. Why women take the instructions that you have to be good in all these dimensions, and it's just impossible. Then we are giving them wrong signals when we say that they have to be good in all these dimensions. Men correct somehow this signal, while women try to be good in all these, and in general they are quite good in all these dimensions, but not. It's impossible to be excellent or perfect in all these dimensions.
Thank you so much.
the question is about the perception of the
Yeah,
criteria.
but I don't think, but I actually think that women are held to a higher standard.
Yes.
So if as a woman you choose not to do the teaching as well because you know that the research is better, then people are going to complain, and we know that teaching evaluations are biased anyhow, right? Then people are going to complain that you're not doing your job in the teaching. So like whether it's the perception or whether it's reality, I think it's an important question.
And double blind.
And yeah.
Yes, one. So,
Thank you, Brenda. Thank you, Maria, for the interesting presentation. I just need a clarification about what junior and senior means. I guess you have track tenure career as a threshold. So maybe that can answer also your question about, because you were surprised, but the reality is that in Italy, the tenure track career begins after 30 years old. So juniors are old women. And that I in part older women than in the rest of Europe.
Yeah.
Very old.
Yeah,
Older.
I will provide this clarification and then we can collect some more questions. Yes, exactly. I think probably we need to be more clear also in the presentation that it's very much related also to Italian context. So junior were tenure track researchers who are not like associate professors still or like at the very beginning of a career as tenured researchers. Also because we were interested in the organizational aspects. So we wanted to interview people who were embedded in the organization for at least quite some time. Definitely for future research, it will be interesting to expand to, for example, research fellow who have less likelihood to remain into the organization, but definitely can provide more nuance on that.
Thank you very much. Thank you very much. Okay. I don't need the microphone except if you want to register. Anyway, it doesn't work. Maybe I detach something. It doesn't work. I'm going to talk without the. I don't need it. I don't. Yeah, hear me, tell me. I think the excellence has something to do with networks. You mean that men are always excellent. The networks men, the work of the networks of men, they're just always excellent. It has something to do, it's not rational at all. And it's true what you said, women have to be excellent everywhere. And it's really what they're being told. This is part of the education. You have to be, when you started, when you're newborn, you have to be such a nice, clean, young girl. You cannot be messy and everything. And I'm sure that in academia it has something to do with the network. The number of people, the number of men are saying, well, this guy is extraordinary. And then you just look at him a few years later, you could say, well, he was really extraordinary. He didn't do anything. No, but really, this is network. That's all.
Thank you. So when it comes to the perception of what is demanded, which might either be, I do agree with the fact that women are held to higher standards to a certain extent, and probably also this causes women to have more performance anxiety and the fact that they perceive they need to prove have achieved these higher standards in more different tasks, and maybe men are less exposed to this. It might be an explanation, so it's definitely something that we can integrate in the analysis. When it comes to the network, so when discussing this excellence mandate, we didn't find like a direct connection to network and isolation, but something that maybe I missed to say, when describing their career trajectories, we discussed about the fact that the women in our sample reported less linear career trajectory, also because they were more likely to report, for example, bad relationship with the supervisor or the research group, so higher isolation within their previous research group that maybe forced them to change career or discipline field at some point. So, I mean, there is definitely potential for relations on that.
And I would like to add, even if you're very good as a woman, you're being told by everyone in the academia that you're not in your place. You're not supposed to be here. Oh, okay, you're very good, so what? Really, and a lot of women have described this fact that they're not supposed to be here, so that, and then they don't get the prizes they should get, and everything. Really, it's really very difficult. And all the women say, well, look at what I had to go through to have a career. And men, they say, okay, just be straight. You know. Sorry.
And also, I would like to add that those demand to be entrepreneur of yourself, as one of the respondents said, it is somehow linked with self-stereotyping in women that prevents them from this behavior. And it impacts somehow their careers.
Do you have any other questions? Thank you so much.
Thank you.
There is a folder with all of our presentation, but I don't know how to retrieve it because I don't know how to use Mac.
Yeah, I don't know how to do that either.
Okay, try.
And plus my eyes are not so good, so very, very small.
I will try.
Okay.
Okay.
Yeah, okay, perfect, thank you.
So let me introduce the speaker. We have René Adams. Is inclusive science better science?
All right. Thanks very much. Can I carry? Yeah, I can carry this. All right. Okay. So I'm gonna stand because I don't want you guys to fall asleep after lunch. Okay. So we've seen a lot of very polished presentations this morning. So this project is very, very preliminary. So actually, I'm here to get feedback on how we can improve this, not to tell you all the amazing things that we did. So I'm really looking forward to some feedback. And basically, where we're headed. So let me actually write something on the board. All right. Idea, publication, right? And so it's thinking about the meritocracy when we talk about the meritocracy. And basically, our point is that ideas are not publications. And this is how we're evaluated, right? But this is what we should really care about, right? And we don't have enough discussion about that. And so this whole diversity discussion is really about, like when people say we need more diversity, they're always saying we need more ideas, right? It should be about more ideas. And yet we know that women on average publish less. I mean, there's lots of papers showing this. And then people think that women are losers, right? So we don't need more diversity because they're not producing, but we shouldn't care about this in the first place, right? And so this project is sort of trying to get at that. you know, sorry, I forgot the microphone. So anyhow, so we're very far from that, but this is part of the point, and it's very much influenced by my own career, because
Lost the presentation.
Yes.
oh,
You might have touched the view.
okay, that's why people sit down, right?
Yeah. Yeah, it's okay.
It's okay. It's okay.
Is it back?
Yeah.
Okay, all right. So I'll try not to. Okay. Okay, so yeah, it's very much influenced by my own career because I'm very interdisciplinary. I publish across fields. Anyone who does interdisciplinary work knows that it's brutal to publish, and so I have fewer publications on average than my male colleagues, and therefore I'm paid less. But I'm doing things like crazy things that I think are much more important than the work of my male colleagues, right? So I think it's unfair. Okay. So I just have this little picture here, and I'll go over to this side, trying to illustrate what we're thinking about. So we're thinking about the role of inclusion and innovation. So what we really should care about in science is innovation, not producing lots and lots of publications, right? Which is how we're evaluated. We're just like producing stuff, but we should be producing innovation, right? And so when we think about diversity, people always say, well, you have more diversity, idea generation should go up, right? And there are studies that show that diverse teams produce more innovative work, for example. There's lots, I would say there's, a fair amount of micro level evidence, so at the individual or team level. There's not a lot of macro level evidence, so that's basically where we're trying to come in. Now, on the other hand, if there's more diverse ideas, we also know that scientific fields are pretty conservative. So there's gatekeepers, and it's very difficult to get new ideas accepted, right? And we have micro level evidence that, for example, women have less success at journals, the rejection rate is higher, women are less cited than men, right? And so, their work is not being read as much. And so to be someone who's trying to bring new ideas to the table, but then having the establishment sort of reject you, makes it hard then to argue that innovation in the field is increasing, right? Because we have, in principle, this should be going on, there should be more innovation, but then we have the whole establishment pushing back. And so it's not actually clear that inclusion leads to better science, which then makes it harder to argue that we should have more inclusion. Okay. So, sort of like, okay, so we're trying to take a direct look at this question of, does a more inclusive scientific field produce more innovative research at the field level, not at the team or individual level? And so we're shifting the focus from individuals or teams to fields, and we're trying to provide a macro level complement to micro level studies. So our answer, just to preview what we think we find, is yes. Now the economists in the room will say it's probably not causal. And there, I agree, maybe we can't say anything about causality, but then we can maybe discuss this. Is it important whether it's causal or not? And so there, I'm not quite sure. So if there's reverse causality, if more inclusive, so like what we argue we find is more inclusiveness leads to more innovativeness. Now suppose it's reverse causality, that means more innovativeness of a field leads to more inclusiveness. Well, that also says something that I think might be important. And so therefore I'm not entirely, so, and this is where we need help, right? Can we do anything about the causal identification? Not so sure. Can we think about framing? Can we push this much further? So, any ideas that you have would be very welcome, but I would like to get your opinion on this. Okay, so the big picture is basically trying to, so the reason that we think having macro level evidence may actually be useful is because, if inclusion is really good for science, then the question is, where does responsibility for changing inclusion lie? And right now, I would say a lot of the responsibility lies with individual institutions. And so there's this evidence that diverse teams produce more innovative research, and that then justifies that universities should try to hire more women or be more inclusive, right? Because then you supposedly produce better research. But then the university can't fix the fact that the journals will be pushing back on the new ideas, right? So you can have a very diverse university, but that doesn't help if the journals are going to be rejecting all this innovative research. So we really need field level intervention. And then I think if we want to argue that fields need to work on this problem, not individual institutions, we need more field level evidence. And right now, a lot of the field level evidence is all about representation. So people say, oh, look, there's a problem in STEM because women are underrepresented, right? But the problem with representation is that it always sounds like it's about fairness, not about quality. And you can always make the quality argument. You can say, well, women are underrepresented because they don't have the ability, because, all the things that people have talked about, right? So the representation argument, I think, is very hard to sell. And so we think having more field level evidence is actually related to the things we should care about, which is like quality of ideas might be useful. And this for me is really an important point. So I started, so I'm a finance academic, and women are very underrepresented. So it's like STEM. So finance and STEM are the worst in terms of scientific fields. Actually, I think finance is worse than STEM. So I have a paper that I wrote recently called The Inequality of Finance. And what we showed is finance is worse than economics and STEM. So it's really bad. And so we started a women's committee. So I co-founded a women's committee of the American Finance Association, which is the most prestigious association for finance academics. And I ran this committee for 5 years. And basically, it was very interesting because whenever we were trying to say, well, we need to fix finance, the other people, the leadership of the American Finance Association, their story was it's all about the pipeline. It's all about the pipeline. And so what we need to do is we need to mentor women to, basically be able to succeed in finance. And our story was no woman wants to enter finance because we haven't fixed the field. If we fix the field, then the pipeline problem will solve itself. Moreover, if you're mentoring people to be just like you, then you're getting rid of all the innovation, right? The whole point is you want different ideas, and then they say, oh, our response to that is let's make you just like us. And so that defeats the purpose, right? So anyhow, so this is where we're trying to, where I think actually we need much more evidence. Okay, so it's a very simple paper right now because, but anyhow. So basically we have measures of, so we're trying to look at fields. So we have potential measures of innovation at the field level, or things we might care about as scientists. And then we're just regressing those measures of innovation on the fraction of women in the field. So very simple. We also have one other measure of inclusion that I'll show you in a second. And then we have some controls. We don't have a lot of controls because this is macro level, but any ideas you have would be very welcome. Our identification right now is pretty simple. We just have fixed effects. So it's cross-country data, cross-field data. We have field, country fixed effects, and year fixed effects. So it's panel data. And we cluster the standard errors at the country level. Okay, so the data that we have is, so it's a country field year panel of field level innovation and inclusion measures plus controls from 1996 to 2022. The data source is Scopus, and SciVal via it's something called Elsevier ICSR Lab. We downloaded the data in 2024. If you tell me we should do a bunch of different measures, unfortunately we can't anymore because they changed this lab, and so this lab doesn't exist. Okay, so which is a real bummer. I think they're probably going to do something else. Okay, so but basically it's Scopus, right? So what is Scopus? It's a database of articles, scientific articles. So Scopus has data on papers, so we know the authors, we know the fields, and we know the topics. This comes from Scopus. So Scopus uses science metrics to classify publication research areas. And so we have a fairly granular definition of fields. So we have about 166 fields. And we have about 180 countries in the sample. So we cover different countries and a fair amount of fields. Now, in 1996, Scopus starts classifying paper topics, and so each paper gets one topic. Okay. So we have publications that are classified into roughly 94,000 topics. Now, the topic classification is a little bit of a black box, so we're relying on Scopus, but basically they do citation linkages. And so they essentially look at clustering of citations, and based on that, they define topics. And then they label the so they find the clusters, and then they label the clusters, and that's based on keywords from titles, abstracts, and author keywords. And so just to give an example, so if we look at articles published between 2013 to 2022 in the Journal of Finance, the topic with the highest number of scholarly outputs is labeled Capital Market Returns, CAPM, Asset Pricing, and that's 64 articles. So that seems to me actually plausible that in the Journal of Finance, which is our main finance journal, the most important topic would be the CAPM, so it doesn't seem completely crazy. Essentially that's the idea. And the second topic is portfolio selection, which is, I would say also is reasonable. Okay, so we use these topics to construct measures of innovation. So we have 4 different measures. So the first one is similar to in the patent literature. They sometimes look at if you cite outside the field, then it's considered to be a more original patent. So we look at the number of unique topics in the cited references of articles. So this is supposed to be an originality measure. Now we have this for each article, and then we average at the country, field, year level. Topic count, we say how many topics are actually do we find in articles at the country, field, year level. And so the idea is like, well, if you have more topics, there's more ideas, right? And then we have interdisciplinarity, so the number of primary fields represented by authors of articles. So each article, we can say, well, how many different fields are the authors classified in? And then we average that at country, field, year level. And then we have a Blau index of diversity, which is 1 minus the sum of squared topic shares among articles published in a given country, field, year. Okay, so our inclusion measures are the percent of women from the number. So basically, we have all authors in a country, field, year, and we say, so unique authors, how many of those are women? That's basically fraction of women in a country, field, year level. And then we also have a measure of non-inclusiveness. So there's this measure, I don't know if you're familiar with this work on field-specific ability beliefs from Leslie et al. 2015. I really like this measure, and we've used it in some other work. And so basically, what it is trying to measure individuals' beliefs regarding the importance of innate talent in the field. So they call it expectations of brilliance. And it's essentially whether people think that you have to be particularly brilliant to do work in the field. And so the actual question is, so they give a questionnaire to faculty and various people in academic fields. And so the question is, for example, one is being a top scholar in your discipline requires a special aptitude that just can't be taught, right? So you have to have innate talent. The second question is, if you want to succeed in this discipline, hard work alone just won't cut it. You need to have an innate gift or talent. And the third one is, with the right amount of effort and dedication, anyone can become a top scholar in your discipline. Or when it comes to this discipline, the most important factors for success are motivation and sustained effort. Raw ability is secondary. And so you see a clear distinction between the first two categories, which are like, oh, you have to be brilliant, and the second two, which is like, oh, you can actually learn this stuff, right? And so this is the graph from Leslie, which shows the field-specific ability beliefs. So the higher that ability belief is, the more weight you place on you have to be brilliant rather than you can learn this stuff. And you can see this by discipline. So the top graph is for STEM fields, and the bottom graph is for non-STEM fields. And so, for example, math scores very highly.
Oh, mathematician.
Yeah, so mathematicians believe that you essentially have to be brilliant to be a mathematician.
You see that all the time.
Now look down here, economics.
Okay, where's economics?
Economics is here,
Okay, it's very high.
very high. So economists also believe that you can't learn economics. Now philosophy sort of makes sense, right?
Like maths.
Yeah, just like math.
Yeah.
But I think the economics being very close to, math and philosophy is pretty interesting. Okay, so and sorry, I didn't explain it. So this is the fraction of, so the downward, so math, these are the scores, right? And the downward slope is the representation of women,
Oh, okay, good.
right? So basically, in fields where there's more belief in you have to be brilliant, there's fewer women. Okay. And so we just did a follow-up study.
Because we can't read what's on the left. What are the disciplines on the left?
The percent of women.
No, the disciplines on the left side of the.
Oh, education,
Oh, and psychology.
earth sciences,
Okay. Because
yeah,
we-
psychology.
Okay, we cannot read. So
Yeah.
I cannot read.
Yeah. Okay, and so we just did a follow-up study where we did a cross-country study where we showed that this holds, so basically ability beliefs are associated negatively with the representation of women. And so we use that as a measure of non-inclusiveness of a field. Okay, so now here's a summary statistics for our data. So it's about 250,506 observations. The only thing that I want to highlight here is this red box. So if you look at topic count is the number of topics covered in a field in a given country in a year. So here's the average. The average is 129. Here's the maximum is 9,799. This turns out to be AI. And so actually we noticed that and we're like, oh, we have to, this is interesting, and we want to pull it out and do a separate analysis, but we haven't done it yet. Here's some time trends. So here we have, and this is sorted by interdisciplinary, no, this is the time trend, sorry. Time trends and topics, so it's 1996 to 2022. This is the percent female. It goes from 22% to 34%, so across all fields, countries, and years, right? So there is a slight increase. I wouldn't say it's huge. And the topics, here, this is probably the most intuitive. It goes from, on average, 100 to 132, so there's an increase. If we look at interdisciplinarity, there's an increase. So The innovation measures are increasing over time, as is the representation of women. So you could say, oh, maybe there's a relationship, right, between representation and innovation. Okay. Now here we just did a sanity check. So we have this measure of interdisciplinarity, which we argue is a measure of innovation. And so what we did is we just said, well, let's regress the topic reference count, which is, do you cite essentially outside of your topic? So it's a measure of originality, and the number of topics, and we have this Blau measure on interdisciplinarity, which is, do you work from people from other fields? And we see that these are all positively associated. So if you work with people from other fields, you cite outside your topic, you cover more topics, and the diversity measure is higher. So working with people outside your field seems to be associated with more ideas. And just some summary statistics. These are the bottom and top 5 fields sorted by interdisciplinarity. So the bottom in terms of interdisciplinarity are philosophy, literary studies, history, mathematics, and law. Okay, so these are the least interdisciplinary fields in our sample. Actually, it's funny because I have a co-author who's a corporate law scholar, and I can totally understand this. Right. So it is very. Any lawyers here?
Former lawyer.
Okay.
Masters in law. Definitely.
Yeah. So you can understand, right?
Yes.
Yeah. Because I'm just like, oh my God, it's a totally different world. So working with someone in law is very, very difficult.
When you talked about, you said general mathematics, the other one is applied mathematics. What's general mathematics?
I don't know. These are the labels that would. Yeah, I don't know. So, but there must be other. Yeah, it's a good question.
Yeah, mathematics.
Yeah, maybe there's applied.
Might go more disciplinary.
Yeah, but then this should be called pure mathematics and not general mathematics. So I don't know why.
Sorry to interrupt you. For the law field, because I use also the Scopus data, the point is that in the law field there are a lot of publication in the national language, and the Scopus doesn't trace these publications because they are mainly in English. So a lot of colleagues in the law departments are in Italian. They publish a lot in Italian. The law is context specific in some way, except for international laws, and so Scopus is not able to represent perfectly some fields, such as this one.
So they don't even give it topics or look at fields. But I think the field thing. But they would have fields, no? Because they would know it's a law publication.
Because you are counting here the number of topics linked to the publications in the field of law, right?
Yeah, so this could be no, but this is sorted by interdisciplinarity. So this is just
but the measure of interdisciplinarity
is
the
a number of
is
people,
related to the topic
authors. Interdisciplinary is related to authors.
Yes, but everything is based on Scopus data, right?
Yeah, but the authors should be classified as lawyers, right? And yeah, but it's a good point. We need to check that.
No. The problem is just if you focus in non-English speaking countries.
Exactly.
But if you just collect data from one country which speaks English, then you don't have this problem with law. But if you use many countries, so if you try to do international comparison, then you end up with a country when English is not the official language. Lawyers in that country, they publish in Italian, for example. So Scopus cannot add this information for this publication.
Okay,
underrepresents these scholars.
Okay, all right, that's a good point. Okay, yeah, I think the interdisciplinary may still be true because it's about the authors, whether they're in the field. But as long, that's an important point. Thank you for that. Okay, so then that was the bottom in terms of interdisciplinarity with some question marks about law, right? Actually, for math, it could also be true because in math, is it still the case that people publish in Russian and French? No, okay.
Everybody's good.
Everyone's okay. All right, but historically, you would publish in
40
different.
years actually. Since 40 years, everybody's.
Okay, all right. Okay, and then the most diverse are basically things related to medical science, actually, which is interesting. So, medicine, biomedical engineering, toxicology, genetics, and hereditary. So these are the most interdisciplinary. So. I also have countries, but I think that's less interesting. Okay, and then here's basically very simple. So we have this panel data, and we're just interested in the relationship between the measures of innovation that we have and the percent female authors. We control for GDP at the country level. We also control for the size of the field at any given point in time based on number of publications. And we put in country fixed effects, field fixed effects, year fixed effects. And essentially what we see is percent female authors is positively related to all of these measures of innovativeness of the field, as we would argue. Now we do another version of this where we use these field-specific ability beliefs from the Leslie paper. So this is basically how much you believe you have to be brilliant to be working in that field. So here we don't have a fraction of women, so we replace the fraction of women with you feel you have to be really brilliant. We have a STEM dummy. Again, the same controls. And here we see that the more brilliant you think you have to be in the field, I would argue the less innovative your field is, right? So fewer topics, so you're less likely to cite outside your field. There's fewer topics, less diversity in topics, and less interdisciplinary. And I guess interdisciplinary makes sense because if you think you have to be super brilliant to be in your field, you're not going to work with other people who are in other fields where, you know, they may not be as brilliant as you, right? So okay, so that's basically all we have so far. And so the conclusion is that, you know, so of course, you know, people will complain about whether it's causal because we have fixed effects, but we don't have any sort of like method for addressing reverse causality. So it's suggestive evidence that inclusion is positively associated with innovation. Now, if we do a thought experiment and we say, well, maybe it is reverse causality, then I would argue, well, that's also interesting, right? Because it means that, you know, this whole question of why are women in some fields and not in others, well, maybe they don't want to go to a field where people are sitting around saying, well, you have to be brilliant. Maybe they want to go to fields where you can look at many different topics, right? And so the innovativeness of the field may be more attractive to women than narrowness, which is something interesting to consider, I think. Now we know that barriers exist, you know, to women's advancement and also to publishing innovative ideas. And so, you know, we're trying to argue that this is sort of, you know, plays to the idea that fields actually need to be thinking about this. So it's not about representation, it's about what kind of science do we want? Do we want fields to be looking at lots of different topics, or do we just want to produce a bunch of papers? And the two are not the same, right? And I think we should have much more of a debate about this. So I always tell people always say, oh, well, the women are not publishing enough. And I always say, I have yet to see a model that says science is improved if we produce more papers. I mean, show me that model, and then if you show me that model, then okay, then we can discuss. But I've never seen a model that says it's really important that everyone produces like 6 papers in 6 years in order to get tenure, because then science will improve. I've never seen that model. So you know, so should we really be talking so much about this, or should we be talking more about this? And then I think the case for diversity becomes more compelling. So that's all I have. Thanks.
be without. So can I take the question? So I'm not a researcher at all, but I had just an idea. You said if there were other ways of looking at innovation, and how about patterns and looking at how many patterns are created in different countries and
Patents.
yes,
I will do it in my research.
and registered by all of
So she has the answer to that.
Okay. It could be another way as well too, and have more insight. So you will do this.
Yeah, we analyze the research, scientific research. We link scientific research to the scientific publications, and then we looked at how scientific publications are cited in patents through the non-patent literature. And so we made this track, and there is a bias also there.
So thank you for your presentation. It's interesting, promising. The economist talking now. I don't see a problem of causality in the sense that you have years, so you can use your time lag to check for causality. That is.
Yeah, sure. We could lag.
Yeah. And I'm more worried about another thing that is, I know how Scopus created those topics, and the problem is that is based on a variety of keywords, and so you have a lot of heterogeneity among fields in terms of how many topics he creates. And that is a problem because, of course, if there are more topics in the field, then you will have that one field is more inclusive or diverse just because there are more topics available in the classification created by Scopus. So you might want to create your topics, and you might want to fix the amount of topic that you can create in each field. So you are sure that those different fields are comparable. Just to give you an example, you have law. Law, what doesn't mean law? There is private law, public law, family law with a specific specialization, but topic that Scopus doesn't capture the specificity, and you just have a law altogether. Why in toxicology?
No. So just to clarify, so law is the field, but then there's a bunch of different topics within law.
Yeah, but then it's the number of topics you have in the field. It doesn't match the number of topics you have in the other field.
But why should it?
Yeah. I mean, if you do not normalize, then you will end up that the publication in some fields are necessarily more diverse, but just because the topic they are being individuated in that field are a higher number of topics.
Yeah, but that's the point, right? So we control for the size of the field. So we have a control for the size of the field, which is number of publications. Okay, so we're saying for the same number of publications, which field, like some fields have more, like mathematics has fewer topics, but then, for some reason, artificial intelligence seems to have tons of topics, right? So I'm not totally sure, like, obviously this law thing we have to look at, but we also have field fixed effects.
But why I think this might be a problem is that because when I did the similar research and then I decided just to stick with the life sciences, that I realized there are too much differences in terms of how journals publications are classified in journals in the different topics. So for example, I'm an innovation and economist, and I have like 20 papers in which I can publish. But then if you look at the people who publish in chemistry, they have journals like Crystallurgica Acta A, Crystallurgica Acta B, and one publication that has certain characteristic cannot even move from a Crystallurgica Acta A from Crystallurgica Acta B. They are completely separated topics, and they generate completely separated topics inside the Scopus. And so even though you are basically talking about crystals, it looks like you're talking about.
Yeah. Okay. So
So
Okay, I mean,
so,
I agree.
yeah.
I agree that classifying topics is pretty difficult, right?
Yeah,
so
yeah,
I agree on
but-
that. But then the question is, why should that be related to diversity?
No, I mean that if you, I think you should normalize the number of topics you have in each field to really capture the diversity of the field.
Okay, and anyhow, maybe we can talk.
Yeah, yeah.
Like, I'm not totally, but anyhow, yeah, let's talk about it. Yeah.
It goes back to what I just said earlier. I was talking about what happened in November last year in the Science Institute and Academy of Science. Scopus is come from Elsevier. The Elsevier took the whole leadership in defining the fields, which is incorrect now. This is what you have to keep in your mind. The change of the CGAP. CGAP is the system of evaluating the quality of the publication. It was a score validated by Elsevier and Springer and all the editing published journal. But it's obsolete now. It is changing. Why? Because the article, you showed the slide, even if you didn't show it, about the country, the country who published a lot and the country who published less, because the articles, it's the article published costs. It's either the country who pay. If you are rich, you're going to have more probably publication. People who do not have money will publish less. So this is what's happening now, especially with the introduction of the artificial intelligence. So you have a bias in the way of publishing in articles. So that's why all that is changing, because the scopus is incomplete, first of all.
Yeah,
in the
Scopus is
teams.
yeah.
Second is because the system of evaluating the published articles is completely obsolete, especially because of the new methodology introduced with the artificial intelligence. The statistic model to test that the quality is valid of a publication is changing, and it's variable. So that's why you cannot say, oh, this paper methodologically has a high impact when the message is wrong and there's no impact. So when you said about the idea has to prevail, this is what's happening. This is done by the European Research Council, and in my opinion, you should liaise with them, because it's all changing, because there are a lot of things which are not correct. I'll give you an example. You talk about mathematics, but in health, you have maybe in one field 10,000 publications on it. None of them has an impact, a clinical impact. They have a good quality, good methodology, but nothing is new. Is it disruptive? No. So where is the innovation? So that's why it's very important to put innovation about, but it is happening. This is what I'm stressing, and it's all the work that the European Research Council is working on it, because the methodology of quality and the qualification of publication is completely changing. And this is what you have to realize now. And it is true. And it is true if you look at all the recent publications in different fields, well, the quality is going down. You have a lot, but the quality is going down.
Yeah, well, so I have my own theory about what is going down, which is that we always stress we should produce more stuff, right? So if we keep on saying we need more publications, then people produce publications because they respond to incentives, right? But then you don't necessarily have a brilliant idea for it.
But it's the system of evaluating the quality of the paper which is changing. It's
Yeah, but I don't know. I don't know anything about this Elsevier model. I mean, that's the first I've heard of it. But I mean, I'm glad to hear that people are talking about this, because I'm not so optimistic. But anyhow, because I haven't heard people talk, because all people talk about is we need more publications. I mean, when we hire people, people are like, how many publications do they have, right? Which is counting. It's just about the counting, right? And so like it'd be great if this like trickles down somehow. But
it is. You can find all the
Yes, but
recession.
everyone say that the quality should be the only criteria, but by the end of the day, when you have different CVs, the committees will end by counting the number of.
Yeah, they
It's a
can.
pity, but it works like that.
But it happened. That's why they are want to change.
Yes,
Imagine
I
they
fully
are
agree
giving
that we have
score.
to change.
Yeah, we have
If an
but I'm not so
institution
optimistic.
having 20 publication, 100 publication, they will have the funding. But the innovation is here. And you have another lab, for example, where they have a lot of innovative ideas, but maybe they publish less, but they don't have the funding. So that's why
Yeah,
this
so-
has to change.
And so that lab is called a woman.
It
It is, it's called a woman, because a woman has lots of innovative ideas, and she publishes less, and so therefore, basically, that's the whole issue, right?
It's the whole issue.
So thank you. I will chair this next session on scientific innovation and gender. And before I'm presenting the next presenters, let me say that it's a pleasure also to participate in a workshop that showcases so much diversity also in terms of disciplinary fields and background. I think it's a rare occasion and there should be more of this kind of workshop. So now I'm presenting Noor Gadban, that will introduce the project Gender Bias in Radar-Driven Vital Sign Monitoring. The floor is yours, and if you need also help with the time management, I'm here.
Thank you. Yeah, see. Yeah, finish. Okay. Hello, everybody. Thank you. Thank you for having me to present my work. This work funded by the Science Commitment of the Sterling Women and Science Chair. First, I would like to introduce myself. I'm postdoc at University of Glasgow. I'm also one of the members of the Royal Society of Edinburgh, and I was a Cara Fellow and L'Oreal UNESCO for Women Science Fellow. So first, I will give you like what this presentation. So I will begin with a brief of introduction and motivation for my work. And after that, I will talk about the data set and methodology of my work, performance, and how we can maybe make the bias in our work less. And we will conclude by the discussion and conclusion. First, we have like many types of monitoring systems.
Maybe use the other one because this one has problems.
This is good.
It works and it doesn't.
Yeah. So we have many types of monitoring systems like radar,
Cameras. Maybe you don't use it.
Yes,
but
but
use
take the other one. Take the other one.
I think this one. I don't know. Okay. So we have many vital signs monitoring system. Before this idea like born, I was in a hospital delivering my daughter. I think lots of born babies died because they don't have any opportunity to measure the vital signs. And also, like elder people.
Really, that's making me confused. Okay, I'll speak. Can you hear me?
Yes.
So I think with myself, how maybe we can save babies and how we can maybe save like elder people who can't maybe put the cables and everything, because all of us know that when we want to like measure our heart rate or maybe respiration rate, maybe we need these cables, we need these. So it's maybe not comfortable, and sometimes of the skin is not good to have like this like cables. So I start thinking what we can do. So one of my colleagues work on radar, and radar can have like a signal that this signal reflects when any person or maybe.
Okay. So these signals reflect when see maybe, for example, wall or human. And when it reflects from the human, it gives us some features for the heart rate and respiration rate. So I start thinking about math, how maybe we can help AI help vital signs monitoring system. So I start building the models to build this vital signs monitoring system and took from the radar. And as we see, the radar is like a very, very simple device, and we can put it in everywhere. For example, we have a privacy because if you want to monitor by cameras, it's not good to put it, for example, in a toilet or anything else. Yeah? And also, it doesn't affect if we wear like a light or heavy clothes because the signals will keep and we will have the good features. So after that, think also about the gender. When I start working with this, I have a big question. Does the women affect in our results in AI or not? So here is the problem or motivation of my work, to see if the female can affect the vital science results from the radar or not. So because most of the studies, I haven't heard that, but I put most. Most studies underrepresented women in their work in AI. And now is responsible AI is like a trend. And one of this to see the effect of the data sets or the woman. So our objective in this work to see the gender bias in radar, also to detect many types of these bias and how can maybe to make this bias less, and also apply this algorithm without affect the accuracy. So really I draw that in Photoshop. This is me. I don't know if it look like me, but this is like our lab in James Watt School of Engineering at University of Glasgow. The people who volunteered to collect the data set, we have here a radar, and also we have like a reference devices to measure if the radar give us good resolution and give results. It's from Veneer company, and it's used in the hospitals. And now I would like to say that our experiments apply in hospital of University of Glasgow. So I start with 16 people and 50% of men and 50% of women. And I do the signal progressing, and I separate the train and validation and test data set for 70, 50, 50. So I did the pre-processing and feature engineering. So I remove the noise using some types of filter. I didn't here put a lot of like mathematical information just to make it clear what did and what I finally see in my projects. And also I apply some filters to separate the heart rate and respiration rate from the radar, because radar give us as one signal, and this signal have these two features. So I want, when I want to build my model in AI, I want the features. So the first thing I did that I used this just only these signals, but when I did my experiments, I see that it's very important to separate these signals and have also some features from breathing, because it's very important in any AI model to have the best feature to train on it. And after that, I synchronized between the radar and the ECG signals, because really some points and some features must be in synchronized signals, because some points is very important, and if they are not signals, they will not give us like a direct and valuable value. And after that, I extract 15 features from both heart rate and respiration rate. So here I built my model, and I really used a hybrid model for this work. So I used LSTM, and also I add to it Dennis layer to gauging and combine all the models together. And I use many classification metrics to see my work for accuracy and recall and the loss, the error, everything for that. So the first result. So no, sorry, this is just only the types of the data set that I trained on my AI model. So first I trained my data set for just only male, female only, and also balance, half male, half female. And after that, the percentage more for male, and finally for the female, that like 75% for more female in the data set. So the classification give me that when we have more female, we have more accuracy. And when we have just only male, it's the lowest accuracy that we have. So see how important in training the AI models. So this also another metrics, but in AI we always focus on accuracy, and also focus on the error. So look, if we have, for example, female only, it's more than if we have just only male, or when we have like a female and male, but male more. But this is very interesting, that is when we have 70% of female, when we want to train that data set, it's very good for our AI model. And also we measure the error, and the error when we have female is less than we have male. So it's 1.80 when we have only female, and when we have female 75%, it's just only 0.7. Here is the distribution of error, and as we see that the dataset effect for the man and woman. And after that, I think, okay, what is the solution? What we can do? So there's like many framework to make this bias list. So I identify sample and measurement and many types of the bias I detected in my model. And after that, and I applied many fairness methods to make this bias list. And also I calculate my result according many different metrics to see what the improvement will be. So I used time chain method. It's just only to make our data balance. So if see that, for example, male less depending on my results, so it will make like female more, and I fine-tuning my models and adjust the threshold for all the steps that I have to make it like a less bias. So we can see that after I did all this, and I told you that I didn't go through like very mathematical things because it will be like a boring and maybe you will not understand that. But I just only mentioned the name of the method that I applied. So look that the error is now less about after we apply that. And the final result for our model when we train it for unseen data is 90.5. And really, it's very good accuracy. And we don't have bias after that. So now we see that balance or maybe female data set is very important for the accuracy in AI, in healthcare, especially in monitoring system, and for the like a promise contactless device in radar. And this accuracy also give us to figure out another question, that just only the fairness or bias from gender or not. Because we have also many factors that we have to figure out in AI models, like ages, that the people who come that come from different country, it will be maybe the accuracy different or not, especially in like these systems that is very important for the health. So we have to figure out the bias that come from different factors. Also, okay, and I mentioned that we have put that as a standard when we want to think about any AI model. It's not like just only like research. So I think maybe one day responsible AI in healthcare have to study different types of data set. It's not just like I want to try it. It's like putting some standards on it. So as I mentioned, I start with like this data set and have just only 60% of people, 60 people, and we have to check more data set from different ages or different countries. So I hope that we will continue this work for this. So thank you so much. This work is has accepted by the University of Glasgow Ethics, and also, as I mentioned, for this funding and this team, me, Dr. Julian, and Professor Jean and Dr. Mustafa. Thank you so much. I appreciate your attention, and I'm ready for any questions. Thank you.
I agree with you.
That's the whole problem with AI, okay? And that's one of the reasons why the AI Act has been written, okay? Because the field, the critical and sensitive field in AI, which covers defense, health, and other strategic areas, you have, and that was one major difference between Europe and the United States, the USA, is the ethical part. That's number one. Number two is to be able to explain how you achieve to that result. So you have to open the black box, okay? And of course, one thing which is typical with AI, specifically in medical research, is that one finding today can be different another day for two reasons. Because now we're no more in Gen AI, we are multi-agents AI, and there is the results can be completely variable depending on the data that's coming in through, and because the machine is learning by itself, it will take into account maybe something new in the future which hasn't been involved in a time T1, let's say, when you did that research. So I think that today we are all in the proof of concept. In health, in particularly, we are completely aware of what AI can bring us, but we depend on two things: the model, the large language model, the visual model language, which are completely different, and more specifically, the databases. So that's why regulation has been very important to implement it before. And I think that's what you have written in your conclusion. And I don't know, UK, which regulation is following. I don't know, because are they following the AI Act or not? I don't know what's the if there's a national law that has been implemented in the specifically in UK, but I think it's the major part of it.
I think it's like general information. Yeah, but UK is considering the ethics in AI.
I'm not sure you have the answer, but I ask anyway. Do you know why when there are more women, the model is better? Did you try to find, because 50-50, it could be logical because it looks like the population that is studied, but yes. And I guess for the, you see, when you want to add every type of age, etc. But I think, I'm not in the research, but I think the difficulty is that we can't find any testers, any people who would like to test some models like this, and so as we have to be sure that we have enough people of each class, I guess it's complicated to add age and country, etc.
Okay. To answer the first question, because female, as I mentioned, that the radar give us like a heart rate and respiration rate signals, is give us better features for breathing. And I see that like 80% of the scientific articles, when I see, they don't mention about integrating breathing also to find the vital signs monitoring system for the radar. So when I analyze the features from women is better than from men. But when we say like if we have like a 50% and 50%, yeah, it's good for like our results. But imagine that the accuracy is very important, and you have elder, for example, person, and this accuracy affect if he has maybe a problem in a home. And for example, this monitoring system is monitored by hospital. This maybe percentage will not give us like good monitoring for him. So this is why it's very important to know which data set configuration we have to start with. I hope that I answer all your questions.
Yeah. So, we don't know exactly why, but we know that
the type of breathing for women is better than female. Yeah, and when you want to extract the features in AI, the signals is better. I'm sorry, but this is what I have, the results. Another question?
And just to be sure to understand, the filtering, the separation between the breathing signal and the other signal is better for women.
Better for women and men, but it's better more than for women.
Okay.
Yeah. Okay, thank you so much for listening. Thank you.
Okay, thank you. So last but not least, Laura Toschi from University of Bologna that will present the research generating technological impact from scientific research, the role of women. Managed to find them.
I think that I sent there, sorry,
If you want
No,
to,
but
the-
maybe-
the-
no.
yes.
No. The lowest one.
Here.
Okay, is it good enough now? Yeah, okay, perfect. Okay.
I think-
my plan works, so
This is how-
this is how I'm working.
Okay, good. Okay.
Okay, thank you so much for the invitation. For me, it's a pleasure to be here to present the research, and I would like really to thank the Women in Science Chair for the possibility to go ahead with this research. So. Just a disclaimer, some of the pictures that you see in the presentation are AI generated. So it's sometimes, I mean, they're not particularly fancy, but like this one, it's not based on data. It's just for giving you an idea of the concept, and I think that it is very useful. So, as I was mentioning before, what it is important for us, the starting point of our research, was to try to explain and try to understand what is the impact of scientific research in terms of technological development. So this is the baseline, and in particular, we would like to understand if women scientists are going to have a lower or greater impact on technological development in respect to their male colleagues. So this is important because, as René was mentioning, ideas are very important because it is from ideas that you can create a particular different lens in approaching problems, and this will have an impact in the way in which industries, corporations, through different types of technological pathways, will going to define the evolution of the innovations that are going to impact our society. So being able to understand the first stage of ideas is particularly relevant. So this is the focus of and let me say the starting point. And here are the objectives of the study that I'm going to tell you. First of all, the context that we are analyzing is a particular context that is the European Research Council grants. So we are talking about scientific excellence, because I think that everybody more or less knows this type of a funding. It is a funding of at the European level for very high level scientific research, and so we have the possibility, as I am an expert evaluator of for the ERC, in particular for the proof of concept. Also, some of my colleagues working on this of these project is linked with the European Research Council, and so we have the possibility to start with some data and then we gather additional data. So the goal, as I was trying to explain before, is to start from these projects. So we have gathered details about the project granted by the European Research Council. And here we distinguished between principal investigators of these projects that were male and female.
we didn't know the gender of the PIs, and we defined a methodology that I'm going to explain for gender detection, because obviously this was not an available data. And then we identify gender disparities along two main directions. So the baseline in terms of approach is this one. So we identify the research projects. From the research project, we identified all of the possible publications that have been generated by these projects. And then we have linked these projects to the patents, because in the patents, like in every type of publication, there is a list of references. These references could be both patents, but also scientific publications. So the scientific publications are included in a specific section that is called non-patent literature. And so we had the possibility to create this link and to see if the scientific research generated by this project granted by the European Research Council are going in some way to inspire technological progress. This is what we call indirect effect, and it is an important effect because here there is nothing that the scientists can do. It is a matter of understanding if this research in particular is cited or not in other in patents. We also had, I'm not going to analyze these different pathways because I didn't have time for analyzing also this other approach, but we also analyzed what we call the direct impact in terms of patents that the PIs, the principal investigators of the projects, declared and applied for and maybe obtained as grants. Obviously, in academia, as we know, there is a huge problem. If you publish something, your probability to obtain a patent is killed because the publication is a point that makes the innovativeness of an innovation, of a new technological development equal to zero, because there is this piece of state of the art. So obviously being able to analyze not only the direct patents, but also the citation through indirect patents, so not the patents obtained by the principal investigator, is very important because in Italy, but I think in a lot of other academic contexts, there is still a lot of work to do in order to let academics understanding that is important first to make patents and then to publish, because obviously you can have a patent and then publish, but the reverse is not possible. So obviously focusing only on patents is not going to...
There's a problem of connection.
Yeah, I just have to not go and make a sleep the document. So being able to analyze also this indirect effect is important because obviously the size of the impact, if we consider only direct patents, is not very big for these problems. So what we do in this project, we did two different things. First, we look at the probability of a scientific research led by female principal investigators or male principal investigator to be cited by patents, and also the number of patents that cited this research. And also we were interested in understanding the presence of geographical spillovers. That means if a female researcher is going to, from University of Bologna, is going to develop a very good research, this influence on technological development is localized in the Bologna area or is able to reach also additional discoveries around the world. And so in this case, we try to analyze we try to geolocalize the countries of all the applicants of the patents citing these publications. So there is, quite a huge work for trying to identify all of these dimensions. And then, last but not least, we try to identify some what we call as boundary conditions, elements that could help in improving the effect of female scientists in support the technological development, and we started analyzing three dimensions, one at the micro, one at the meso, and one at the macro level. So at the principal investigator level, characteristic of the PI, characteristics of the project, and the characteristics of the regional context in which the scientist is operating. So this is the flow, and I will show you some results regarding this. The project finished with, let me say, with these 2 points. The point about the boundary conditions, it is something that we are working on now, because we are interested to understand. So the gap exists also in terms of support of scientific research led by female scientists toward technological development. So we are interested now to understand what can be done to decrease this bias, this gender gap. So, as I mentioned, there is a huge work in terms of combining different data sources. So there are a lot of data here. And so the team has an interdisciplinary nature. There is the dimension of innovation management. And so it's me, I'm a professor of entrepreneurship and innovation at the University of Bologna. Recently, I also became a president of the incubator of the University of Bologna, and this is a very important field where I can see also a lot of these disparities on the entrepreneurship context. That is another area where I would like to explore a little bit the presence of this gap. Professor Federico Munari is my colleague, and Dr. Enrica Ighi is another colleague that now is in Brazil. From the other side, there is the dimension of information systems, data science. Professor Angelo Di Iorio and Michele Pellegrini from the Department of Computer Science of the University of Bologna helped us in analyzing and cleaning all the data that we had to use for this project. So, as I was mentioning here, the idea, just to recap, is to look first, just as a descriptive statistics, the distribution of a project, of ERC projects around Europe, distinguish it between female and male principal investigators. Obviously, this is just a starting point. Here, there is a problem related to the dimension of a number of people applying for, so we can't do anything about this, but just for giving you an idea that there are less projects led by female. Then we are going to analyze the innovation dimensions to assess gender differences in their ability to commercialize scientific output through their research. And then we would like to investigate the role of some elements, and in particular we took into consideration the seniority of the researcher, the interdisciplinarity nature of the project itself, and also the level of innovativeness of the region, of the country, where the principal investigator, the research has been developed, in order to see maybe if there are some contextual factors that could help decreasing this sort of bias. Obviously, we are still working on this last part, so if you have ideas about possible moderators, possible elements that could be important to consider, we would be very happy to test and to see if there is something that we can tell you of interest. So, in terms of data, this connection that I was trying to depict it now, we started, as I was saying, from a European Research Council funded grant. And so we identified from ERCEA, that is a database available from the European Research Council, and on Cordis, we identify all the ERC projects under the framework FP7 and Horizon 2020. Now we are working also on the next pool of a project, because obviously here there is a time coverage that is concluding earlier in respect to the period right now, but so we are trying to include also recent projects.
Then from here we use the Scopus, and in the previous, in one of the previous papers by Irenese, so we use the Scopus to identify the publications linked to the grants, and then we use the PATSAT for identifying all the possible patents that could be linked to these publications. In addition, for the direct patents, so the patents directly granted by the APIs of the project, again, we use the ERCIA database, the database from the European Research Councils. In addition, we also try to include two additional elements. As I was mentioning, we do not have any idea about the gender of the APIs because it was a private element that the ERC was not able to give us. So we integrate artificial intelligence for gender detection. And also we try to gather, but we are still working on this data, so it is a work in progress also for this last part. We were curious to see if there is a bias also on another dimension of dissemination of scientific research, that is through social media. So LinkedIn, Facebook, Twitter, because there could be also an effect there, and so we would like if there is some differences. So this is the size of the sample. We analyzed 6,671 projects after a first cleaning. These projects are linked to more than 172,000 publications. And these publications are cited by a little bit less than 35,000 patents. So, as you can understand, there is a huge effort for what concern data cleaning, and this is why we had to refer also to colleague of the data science department. For what concern, let me talk a little bit, even if I'm not the expert, and I'm sorry if it is a little bit small here, but what I want to show here is what we implemented in order to identify the gender of the principal investigator. So this is a methodology that could be easily applied for public profiles. So obviously the studies in general tend to use Genderize. That is an app where you can put the name of the person, you can also include the ethnicity, and it counts for this combination of dimensions, so it is absolutely a good source. We wanted to be sure about this dimension, given the focus of this research on this, and then we search public profile, and we used two techniques. One is going to analyze the approaches of visual recognition, so we analyze the images in the public profiles of academics, and then we also analyze the CVs, the biographies in these websites through the content, through the use of pronouns she or he, in order to be able to be sure that the gender was identified correctly. And so now we use just the majority of green light for female PI in respect to red lights, but we are working also to improve this methodology. Okay, so let me give you some statistics, some data, some results, if you are okay with the approach that we used. So these are just two descriptive statistics in terms of distribution of ERC projects. And you can see that only 23% of ERC projects are led by female principal investigators. And this gap is particularly big in Central and Eastern European countries. I have a report in case I can share with you to see with the specific countries. Obviously, as I say here, there is a lower participation of women in the early stage of the process, as we saw in previous research. So the problem is there. It is not something specific to the ERC, but obviously this is something that impacts also this specific context. Here I analyzed the different grants that ERC is considering because there are three different types of grants, starting grants, advanced grants, and consolidator grants that are different depending on the stage of development of the career of the PIs, and this is a proxy of the seniority of the principal investigator. And again, here you can see that, not again, actually PIs in the early stage careers are more for female, so they tend to have, let me say, to try to give an identity to their profile earlier in their career. So this is particularly interesting as a result and could be analyzed. So there are more applications in the starting grant in respect to the consolidator and advanced grant, in other words. In terms of, obviously, disciplines, the ERC consider three macro categories. There is a social sciences and humanities, a physical engineering, and life sciences. I do not comment about these. We know the problem. And there are the underrepresentation in particular for physical engineering. But as you can see, there is not a problem for other disciplines. For what concerns the results, let me go to the first research question that was scientific research led by female scientists. Produce less influence on the technological development through their scientific publication. So what we find is that obviously the answer is less. It is less likely that patents cite scientific publications where the first author or the main author is a female scientist. And this is true also in terms of number of patents. So we look both at the probability, but also to the number of patents. Here, I know that it is a little bit small. This is why I put the synthesis of the research, but you can see that in yellow are the three the different specifications. This is just a cut of the different regressions, but you can see that the effect is always negative and stable. And very significant, both analyzing yellow dummy patents, probability to be cited, and the number of patent citations. And then so this is the first results. In terms of geographical spillover, that was our second point. We did two things. We analyzed both the mean distance that scientific research is able to reach, and so we analyzed the host institution, so we geolocalized the host institution where the principal investigator is developing the project, and we gather all the details about the applicants of the grants, of the patents, citing these publications, and we created different types of measures of distance. So one measure is the mean distance, and in terms of mean distance, there are no specific differences. This variable is not statistically significant. What is different is the variable that we call the diversity, geographical diversity. That means how many different countries these publications is able to reach. Okay, so are two different dimensions. One, it is the highest distance, mean, we have several proxies, and the second one instead is in terms of heterogeneity. And here you can see the first two columns, it is about the mean distance. There is a negative effect, but it is not significant. While in terms of diversity, that is proxy, that's the different number of countries of the patents, we have a negative and statistically significant coefficient. And so this means that research led by female PIs the research is able to go in one main direction in respect to a portfolio direction that characterize more the scientific research led by male scientists. We also analyzed, and again, this is a work in progress in terms of social media. This is a synthetic representation of what we notice. We notice that there is so women tend to use less social media in respect to men. But in terms of interest, because we analyzed the like on Facebook, the reaction on Twitter, all the different tweets, we were able to see, so these are the real data, we can see that male are able to have more citations on social media. So this is a proxy of the interest generated on these social platforms. But if we go to the right, you are considering, let me say, researchers that have a lot of interest. And you can see that if for the research that captures a lot of interest, the difference is not so big. So this is a good message. So there is in general a bias, but the quality of the research is what is really important, because when there is a very high attention, what is leading the attention is not the gender of the PI, but really is the quality of the research. Finally, again, this is a work in progress, so I just try to give you what we found till now. We have seen a positive moderating effect of seniority. So this means that in this case, seniority is also measured in terms of experience of the PIs. So if the PIs has a lot of experience, also in terms of publications, in terms of years of tenure tracks and tenure track profiles, we have different proxies. We see that seniority plays a moderating effect, and so the gap decreases. But when we analyze the research interdisciplinarity and the regional innovation, we do not find at the moment a significant effect. So if the principal investigator, so the female scientist leading the research, is let me say, is publishing in an interdisciplinary way, this doesn't help. This is surprising, because interdisciplinarity should suggest that there is the ability to reach more areas of interest, and so there could be an improvement in decreasing the gap, but for the moment this doesn't happen. And at the same time, we tried with regional innovation, with the idea that if a scientist is embedded in a context where there is a lot of dynamisms in terms of innovation, maybe the difference could be less pronounced in respect to another type of countries. But also in this case, there is not any type of significant moderating effect. But we still are working on this moderator, and I would be very happy to have some suggestions about this. In terms of limitations of this study, obviously we are focusing in terms of gender on the principal investigator, so the person, the scientist who submitted the project. Unfortunately, we are not able to analyze the team. So we would like to explore some ways to capture the fact that, okay, the PI is a woman, but there is a team that is heterogeneous, and maybe this heterogeneity within the team could help in explaining some results. What we are doing now as a proxy is that when we measure the publications generated by the project, we suppose that the co-authors are part of the team. In general, this is what happens. So we are measuring something related to the team gender diversity through this proxy, but obviously we know that it is not precise. But unfortunately, it is impossible to have this type of data. But for sure, thinking about in terms of team level instead of PI, single PI level, it is something that could be very important for the next research. Okay, so this is just to conclude. Obviously, we have to analyze something more related to the funding, because we have seen that there are some problems related also to the fact that there are not so many female researchers who obtain the grant. Also in this case, we do not have the number of applications and we are not able to see if there is a rejection higher for female PIs in respect to male PIs. But 23% is not high, so we need to focus a little bit more on this, and maybe in terms of policy implications, obviously having something in terms of funding policies could be important. And obviously there is obviously something in terms of policy needs also at the level of the organization, of the university. So there could be a lot of pathways that we have to interplay in order to try to decrease this gap. But for the moment, this is my contact. If you are interested also to have some more details about the project and about this data. And thank you for the attention, and happy to answer some questions. Yeah?
I think we need the microphone for recording issues, but we can.
Yes, it's better with the microphone
Okay.
recording.
Okay. Sorry.
I can congratulate you. I agree with you that possibly the research has to be made by the team rather than PI. You won't find, because this is how it's done, especially for the grant coming from Horizon 2020 and Horizon 2030. It's the team rather than the name. My question to you is, I can speak mostly about the health care and the health industry. Today the patents are obtained, okay? Well, in France, this is how we do it with, we call it the startup nation, okay? So you have, it's better to apply for a patent for your medical device, then you publish. This is the way to do it. So my question is, how is it done in Italy, for example, for medical device? Because it's very easy now. And I know that, for example, last year, France was number one in the number of patents in the healthcare industry. And because this is the way to do it, because it's even easier once you have the patent to apply for the research and then to publish, because then you have a direct link of the results. So I don't know in Italy who is in charge of registering the patent for.
So actually, I do not either, in the sense that so I do not have knowledge of specific the healthcare field. In general, what happens is that at the University of Bologna, at least, we have the knowledge transfer office. Who is in charge for helping academic researchers following all the process for patent applications and patent grant. Obviously, the process is the same everywhere, in the sense that the patent is submitted to the local patent office. And obviously, if you are interested only on Italy or some European countries, you refer to the European Patent Office mainly. Indeed, here we have the majority, 65-70% of patents that are EP, so European patents, but we also have patents from the US Patent Office or the Japanese Patent Office or the China Patent Office, but it is obviously a lower number because we are analyzing European researchers. But the approach here, from the academic to the patent office, there is the knowledge transfer office helping in that situation. In the universities where there is not this institution, I don't know. I think this is what I was mentioning as a problem, because there is not this awareness, and this is one of my points. We have to increase also the awareness in terms of first patents and then publications. But it could be interesting, maybe I could think about also some moderators effect in terms of what is the process supporting patent submission and all the process, the steps of the process.
And to help you to have the numbers, in Europe, you have two sites. If you want to have the full number of trials, it's clinicaltrial.gov.
Okay.
Where you have all the list of the clinical trial with all the scientific names, and the new one is Udmed. Udemy, you have also the list, so you can find, and then you can see the gender gap if it exists or not.
Okay.
But this is the exhaustive list in Europe to have it.
Okay, no, thank you so much.
So I was wondering, there's a recent paper that looks at citation patterns for academic papers. And what they do is they look at whether papers should have been cited but are not cited.
Okay.
And I was
More
wondering,
specific characteristics of
yeah,
the
so
data.
like, so you say like, oh, in this topic, so like 2 papers on the same topic, like ideally both papers should be cited, but then the paper by the woman is not cited, even though it seems like it should be. And I was wondering if you could do something similar, because I think that'd be super interesting.
Yeah.
If you say like, oh, for a patent in this area, should it be
Has
cited?
characteristics too, but
Yeah, but doesn't do it. So
can you send me the reference to this?
Yeah,
paper?
yeah.
Maybe it could be interesting.
Yeah, but
Yeah.
I mean, this is a problem also because if we had the also the applications, we wanted to apply a method to see, you know, the 10% of researchers who didn't obtain and the 10% who obtained because they are close to the threshold of being admitted or not. But unfortunately, this data, I will search for other contexts to try to test for this, because I think that there are a lot of other things to do in this respect, in this regard.
It's just a remark. I think that it's not a problem to focus on the co-authors instead of the members of the team, because being or not member of the team is, first you have connections, but it's more important to know with whom the principal investigator works and publish, rather than to know if someone is on the list of the team members. And there is some lag between the application in order to obtain an ERC and the life of the grant, and sometimes you have new researchers that join informally the team and co-publish with the PI, and it's more important than the exact list of members.
Yes, I agree. There are a lot ghost team members, and no, this is absolutely true. The point, maybe the composition of the team of the project is more important than ex post co-authors in the selection process, because obviously there you are evaluating the team, and maybe you put some names just because this person has a particular reputation, is important, but for this type of research, maybe indeed we are using that proxy, and for the moment we are not criticized in that sense. But we would like to explore, yes, more these types of dynamics, maybe in other settings it could be useful.
Any other questions? Thank you so much.
Thank you.
I just want to thank all the participants, and in particular all the presenters. Then thank you very much for this day full of interesting discussions and presentations. And just to let you know that we have a round table at 5:45, then a quarter to 6, in another room. Then it's in the second floor, and it's in French. Then it's not an academic discussion. It will be a large audience discussion, and among the participants there are members of the Senate, former minister, but also researchers, and in particular Isabelle will be with us. Then you are all welcome at the second floor, Salle Raymond Aron. Then it's on the other part of the building,